So my slides are mostly on the UK node aspect, but I'll kind of maybe mention a few things. So the dots there are all of the people, all of the different groups worldwide who were taking part in the hackathon. So it was very much a global thing, kind of both northern and southern hemisphere. So it's kind of spread, reasonably well around the world. And then each node had kind of its own topic or topics that it was working on. So for the UK node, there were 65 registered participants plus a bunch of others. So Malalo from Cape Town specifically was in on the UK node, came to do some work on MCSs. And then there was support teams from all of those groups that were producing the simulations and doing any of the clever technical things. And we'd done kind of pre-tracking of the storms and things. And then for the UK, there was particularly work on interscale, so particularly going from small scale and how things do project in energy up to larger scale, work on aerosols and work on organized convection involved in kind of tropical storms and MCSs. So each node again had a science plan and science questions. So what things were they particularly aiming to get from the week? What things were they analyzing? So we can share the slides later, so I won't kind of go through this, but as I say, each had that. And then for the UK node, so we had kind of 5 and 10 kilometer global simulations, but then we also had regional simulations driven by those global simulations to look at some of these aspects of kind of regional downscaling, but also where do the regional downscale models miss out on how those smaller scales are then kind of projecting into the larger scales. So there was a package that Leeds showing kind of some of the diagnostics that looked at how the energy goes from the small scale to the large scale. We had some goals. I think we achieved quite a few of those, and then there was a program through the week. And then at particular times of the day, one of the nodes from worldwide would then sync to, so the UK one in particular synced to the US nodes, and we had a discussion at the end of our day and the start of their day about what we'd found out and what they were going to do and what they'd done the previous day. So I will leave it there and pass over. I can share those slides later.
Great, thanks, Malcolm. Fabi, do you want to share your slides as well?
Yeah, hi from my side. Maybe some more slides from an EERIE cloud perspective. So as you know, we have this new infrastructure within EERIE, and that was used also for the global hackathon, and especially for one specific data set, a simulation of IFS FESOM on high resolution, so 2.8 kilometers. Because due to some organizational reason, this is through EERIE Cloud and not on DKRZ. So that means if we could create a nice EERIE Cloud access statistics after the week and have a kind of more meaningful statistics in comparison to all the other times. Two more statistical facts. So overall in this global hackathon, we had 650 participants registered, and data that was hosted exceeds the 10 petabytes of usable data. So if it's pressed in the cloud, it's definitely larger than 1 petabyte. Yeah, kind of successful, I guess. So after on the access, and you can see that we have bytes which were going through EERIE Cloud to users all around the world, about 200 users cloud during that week, and on Wednesday we reached the 100 megabytes per second. And afterwards, the EERIE cloud couldn't handle the amount of requests, so it was an underestimation of the run for the data actually. So the EERIE cloud was not scaled up for this amount of access. Yeah, so we have 6 EERIE data sets per simulation, so in total 12. In the next pie charts, which that was, we can say that about 3,000 times any data set was opened through EERIE cloud, and that makes about 10 open data sets per user. This is kind of an estimation. And kind of a new statistics that you probably don't get SGF because you have this large EERIE data sets aggregation, so you can the ratio of accesses for larger aggregations. Taken from this pie charts is that 2D data was more accessed than 3D data in both data sets. Actually, the one that was only accessible through EERIE cloud. And then one important difference to, for example, ESGF is that hourly data was also more accessed than monthly data. And this is because the hackathon had a focus on processes and community for many other use cases have rather it's where we would expect more monthly accesses. For Zoom level, it's not so clear. So for the Zoom level here, which is 7, 2D data was was more access on the lower Zoom level. For 3D hourly data resolution. So this is not so clear if there's a tendency in what is more requested. Variables, if you look for share, you can see on first glance that total precipitation was accessed the most, but then you can also find that there's cover, meaning that if you add both, then cloud cover was the most interesting parameter. And so fraction of cloud cover is in the 3D data set. That's why total cloud cover is a 2D variable. And 7 of all 81 variables make 75% of all requests. And then another, and my final slide here. So this is also a new statistic that we can have with EERIE cloud per chunk. And since the data sets will, it's also per time step, because one chunk is always the entire globe in grid. And then you can see, and this is have to find reasons for that. It's not clear why. Surface temperature was accessed the most, about 1,000 times from all the clients. First chunk of this was accessed most, and this is in contrast to the overall rather interest in atmospheric. In the end, people also look at least sea surface temperature. Yeah. That's from my side.
That's great. Thanks, Fabi. Rohit, do you want to share your impressions?
Yeah. So hope it's full screen now. So basically, I will give you an update on the Hamburg node, where few of us from AVI represented EERIE. So basically, Nikolai could not be here today, so I will show some of the things that he did and also me. And so here, what you're seeing here is also a wind speed video that over the Arctic that Nikolai made. Basically, if you really carefully look at it, you will see some structures in the wind speed that appears over the Arctic, which could be in line with the sea ice leads. So it was an idea to check if the sea ice leads have some effect in the winds over the Arctic. So basically in Hamburg was one of the largest participants in the global hackathon. So according to the registration that was made, the highest participants was in Hamburg, second Beijing. I don't know, it was a figure during the hackathon, maybe afterwards it was revised. So during this hackathon from AVI, we three were there from EERIE, And we tried to do a little bit of analysis of different aspects that was provided during the hackathon. One of the thing was there was a TCO 399 run with the AMIP setup done by Matthias, I think, from EERIE, and also there was a coupled run. So we have a same run for almost a year or so in AMIP uncoupled, and we could compare them. So here is a comparison of 2-meter temperature, diurnal amplitude, and in the TCO 3995, I think the configuration. TCO 3999, so it's like 2.8 kilometers, and you can see the difference in the diurnal amplitude that can be seen in the bottom. Kind of interesting because the atmospheric models are the same, but over the lands we have a difference in the diurnal amplitude during that, if that year is concerned. So something was we thought is interesting. There are a lot of things happened, a lot of analysis from different groups. I'm just showing some part that we have performed. So here also the same run, so it was all started with 2020 initial conditions, and here the wind speed is also shown from the eastern side of the North America, and you can, it's all initialized with the same condition, and the point here is to show how the winds are getting different, the speeds, the structures from observation. So ERA 5 is here, they're all initialized same, and the first one is TCO 399 for the IFS, and also you can see in different models the evolution is different. There is also a lot of small structures in the icon model that you cannot see in the IFS. There's a lot of small structures in the pattern. So also there are other models which also did the same simulations, but there could be an issue with the data processing, but at least for the IFS and icon, you can see the features compared to the ERA 5. And going forward, next is also from Destiny, they provided storyline simulations. So if you can, we also learned how to access the Destiny simulations. And here I'm showing that one event that we could track during that, in that storyline simulation. So we had the historical nudged simulation using IFS, and you can see one tropical cyclone that was Lota. It happens in 2020, and then here you can see the same cyclone if we put it in a +2K storyline situations with the nudged winds. So the winds are basically nudged, so but it's not nudged in all wave numbers, so there should be some difference. So here in the bottom you see some difference, and also although the wind differences are not so prominent, you can see the precipitations, how the structure in the cyclone, the precipitations change. So there was some exploration of this storyline simulation in different aspects. So these are one of the aspects. Kind of, that's all for now. I just showed some experiments that we explored there, and also explored other features. Yeah.
That's great. Thank you so much. So thanks to all those 3 folks for sharing their impressions.